What's up, guys? It's Mr. Brengle, and today we're going to start looking at our acceleration math practice problems. And we're going to jump right in here to numbers 1 and 2. So at this point, you should have already gone over the acceleration equation flowchart, how to pick the correct equation for an acceleration math problem, and we have already done 5 example problems together. So these practice problems would be for you to do on your own, and this video is just if you need additional help or maybe you were absent and want to make sure you got the right answer. But please try to complete these problems on your own and then use this as a resource to go back and correct things or confirm answers. All right, jumping right into it then, which we already jumped right into it, and then we didn't, and now we are. A jumbo jet taxiing down the runway receives word that it must return to the gate to pick up an important passenger who is late for his connecting flight, which would never actually happen. The jet is traveling at 45 meters per second when the pilot receives the message. What is the acceleration of the plane? So that's what it's asking us to solve for there. What is the acceleration of the plane if it takes the pilot 5 seconds to bring the plane to a halt? All of these things are important here. So first we have to understand that the jet here is slowing down, right? It starts at 45 meters per second. It ends at a halt, which would be 0 meters per second. So let's go ahead and write down our initial velocity here is equal to 45 meters per second. The final velocity is 0 meters per second. It tells us that it took 5 seconds to do this, so we'll write that down. And then it says what is the acceleration of the plane. So now we want to go to our flow chart and to help us pick an equation. Again, you cannot use that on the test, but you can use it to get yourself familiarized with how to do this. The first question we want to ask is, did this problem give us a number for or ask us to solve for a change in position, which would be delta x or delta y, depending on if it's horizontal or vertical. And we can see over here that we did not write delta x or delta y down anywhere. We have a lot of things here, but not that. And when you get to that, when you answer no, we do not need change in position. It's very simple. You are going to use equation number 1 on the flowchart, which would be the base acceleration equation, final velocity minus initial velocity divided by time. So we will now plug our numbers in. Just be careful with final and initial velocity. The final velocity is 0 meters per second minus the initial velocity of 45 meters per second. And then the time span, which was 5 seconds. So you can see here that the acceleration is going to be equal to negative 45 meters per second divided by 5 seconds. 45 divided by 5 is 9, so this is going to be an acceleration of negative 9 meter per second squared. I always encourage you to make sure you get that same number in a calculator. Just don't just take my word for it and write it down once you see the answer. And then we want to think, does it make sense that this answer is negative? And it does, because it told us the initial velocity of the jet was 45 meters per second, which is a positive number. That indicates that the object is moving in the positive direction. If the plane is slowing down, acceleration must be in the opposite direction, which would be, in this case, negative, and so this does make sense. Well, let's move on to number 2. Billy, a mountain goat, is rock climbing on his favorite slope one sunny spring morning when a rock comes hurtling towards him from a ledge 40 meters above. Billy ducks and avoids injury. How fast is the rock traveling when it passes Billy? So the first thing it tells us is that he's on a rock comes from 40 meters above him. So if you kind of think about here's a cliff and I don't know, here's a little cutout and maybe the goat is right here, and then a rock is just kind of tumbles down and it passes him, right? And so it's wanting us to find out how fast is the rock traveling when it passes Billy. So the rock starts up here with an initial velocity of 0 meters per second, and then something happens, it dislodges and it falls. We're solving for that final velocity, but we were not told that the initial velocity is 0. That is something that we need to understand when an object is dropped from rest. Initial velocity is 0. The other thing that we would be missing here that is not told to us, but we need to understand, is that that rock is going to accelerate because of gravity. And gravity causes all objects to accelerate at 9.81 meters per second squared. We round up to 10 meters per second squared in this class. And that would be pointed down. Also, your velocities are pointed down, so we don't have to mess with positive or negative here. The final thing was just that delta y, the height here, was 40 meters. So now we want to pick an equation. We have all the things that we can think of here. Did this problem give us a number for or ask us to solve for change in position? The answer here is yes. The 40 meters would be the vertical change in position of the rock from where it fell to, or where it started to where Billy is. So we are going to eliminate equation number 1. We'll move on to our second question, which is, did this problem give us a number for or ask us to solve for time? And the answer to that is no. It did not give us time. It did not ask us to solve for time. So we do not want to use equation 2. We want to use equation 3, which is going to be VF squared is equal to VI squared plus 2. We're going to sub in G for A, and we're going to sub in delta Y for delta X. Now we can plug numbers in and solve. So we are solving for the final velocity. Just don't forget the squared is on that. You're going to need square root at the end to get that number. Initial velocity is 0 plus, now remember you're multiplying all of this together, 2 times 10 meters per second squared times 40 meters. Okay, so VF squared is going to be equal to 40 times 10 is 400 times 2 is 800. This is actually, if we're keeping track of units, it would be a meter squared over a second squared. You don't have to do that in the problem as long as you get the units right at the end. We do need to square root both sides of this equation. And then we find out that our final velocity is equal to, I'm going to plug this into my calculator actually to make sure that we get this right. Square root of 800 is 28.28. If we're doing sig figs, 28.3 meters per second. That would be the velocity of the rock as it passes Billy. So it starts from 0 meters per second. It starts speeding up as it falls. By the time it reaches Billy, it's moving 28.3 meters per second. All right, guys, that concludes this video, which covers problems 1 and 2 on your acceleration math practice problems. Thanks for sticking with me, and I hope you learned something.